This chart maps planetary distance from the Sun against average atmospheric temperature. As you move further out into the solar system, the environment naturally gets colder. Following that logic, Neptune should be the most frigid world in our neighborhood. It sits an entire billion kilometers further from the Sun than the seventh planet, Uranus. But look at the data point for Uranus. Instead of following the curve, its temperature plunges completely below Neptune, bottoming out at roughly -224 degrees Celsius. That drop makes Uranus the coldest planetary atmosphere we have ever measured. For thousands of years, observers missed this anomaly entirely. From Earth, Uranus is faint and moves so slowly across the sky that ancient astronomers mistook it for a stationary, featureless star. Even through early telescopes, the planet looked like a peaceful, pale blue sphere in the dark. But beneath those calm clouds is a frozen environment that actively defies standard planetary physics. This thermal deficit represents a broken internal mechanism. Uranus underwent a cataclysmic event that left it completely out of step with the rest of the solar system. Sunlight out here is weak, only 1/400th as strong as what we feel on Earth. But the true cause of this record-breaking cold is that Uranus releases almost zero internal heat into space. Other gas giants operate differently. Jupiter and Saturn radiate massive amounts of excess internal heat, driving enormous visible weather patterns across their surfaces. If you plunge beneath the deceptive turquoise methane clouds of Uranus, you won't find a hot active core pushing energy outward. Instead, you find an ice giant. There is no solid icy surface to stand on. You simply descend into an increasingly dense, high-pressure soup of water, ammonia, and methane. Down in the absolute darkness of this chemical crush, conditions are incredibly hostile. Atmospheric winds race around the planet at speeds up to 900 kilometers per hour. Despite having a dead internal engine, these massive storms tear through the atmosphere, pushing weather systems through seasons that each last 84 Earth years. A planet with violent weather and zero internal heat is a world suffering from a systemic malfunction. To figure out why the heat is trapped, scientists had to look at how the planet moves. This 3D simulation illustrates the leading theory. Unlike Earth, which spins somewhat like a top, Uranus is tilted at roughly 98 degrees. It literally rolls along its orbital path on its side. Because of this extreme angle, one pole faces the Sun continuously for decades, while the other is locked in pitch-black winter for half a Uranian year. Planets don't naturally form sideways. The current consensus is that a catastrophic impact knocked the world over, scrambling its interior layers and permanently trapping its internal heat deep inside. Humanity's only direct physical evidence of this violent past comes from a single visitor. In 1986, Voyager 2 flew past Uranus at high speed. The spacecraft's instruments detected features of a chaotic history, a magnetic field completely offset from the planet's center, and a faint system of dark, dusty rings. Voyager also captured images of Uranus's strange family of moons. The most jarring is Miranda, a world that looks like it was completely shattered and haphazardly stitched back together. Miranda's surface is heavily scarred by deep grooves and jagged ridges. One massive cliff face rises roughly 20 kilometers above the surrounding terrain, more than twice the height of Mount Everest. The shattered surface of Miranda, the lopsided magnetic field, and the 98-degree tilt are all results of the collision that broke Uranus and left it frozen in time. Voyager 2 gathered all this data in a matter of hours. It couldn't enter orbit, and it couldn't stay to watch the planet's extreme seasons unfold. Compared to the fleet of rovers tracking across Mars, or the long-term orbiters we sent to study Jupiter and Saturn, Uranus sits almost entirely untouched by modern exploration. We need to understand this environment because ice giants are incredibly common throughout the universe. Knowing exactly how they form and behave is crucial to understanding planetary physics as a whole. Because it moves so slowly in the night sky, it tricked early humanity into ignoring it, disguising the solar system's most extreme environment as just another star. Today, this sideways world continues its silent 84-year orbit. It is waiting for a spacecraft to finally return, enter its atmosphere, and stay. Until we go back, Uranus remains the ultimate cold case. Its depths remain unknown, simply because we have barely looked.